Okay, students, so we are starting a class. Let us wait for 2 more minutes so that all of you can join. Okay, I'm audible. Let me see the YouTube view, what's happening here. Okay, so we are going to start the class now. Audible here? Hai? Yes. So nobody have joined. Only 2 participants are there. Let's wait for the students to join. Acha, see here. See, first of all, we'll go through the lenses. Okay. First of all, we'll go through the lenses and hold on. I'm audible clearly? Audibility is fine. That's cool. Stop finding it. Queue here and yes. Chalo. So first of all, let us go through the lenses without wasting the time. Today I want to complete this chapter. Okay, all of you. Today I want to complete this chapter. So first is this. It's refraction through thin lenses. Okay. So this is what topic? A lens. So what a lens is defined? A lens is a transparent medium bounded by 2 refracting surfaces such that at least one of the refracting surfaces is curved. Okay? A lens is a transparent medium bounded by 2 refracting surfaces such that at least, this is written as what? At least one of the refracting surfaces is curved or spherical. Got it? Types of lenses. So what does it mean? This definition means what? I'm explaining you, just hold on. See, we are having a lens structure here. What actually is lenses? So if I talk on the next slide, some random slide, see, suppose not this, here only. So see, we have studied the refraction through refracting surfaces. Hai? That is, if we are having a refracting surface like this, hai? And if the object is placed here somewhat, okay, so we have seen this thing, images are formed here like this on the other side. And we've seen a formula. What was the formula? If this is N2 refractive index, this is N1 refractive index. N2 by V minus N1 by U. This will be N2 minus N1 by R. Fine. Okay. So when we join these kind of refracting surfaces together, this one and say this one like this. So we get a lens like this, which is known as convexo-convex lens. It is also known as biconvex lens. Remember, this is convexo-convex lens. It is also known as biconvex lens. And this is known as equiconvex lens. Equi matlab having the same radius of curvature. Remember. So these both of the surfaces, this pair of surface and this pair of surface connected together are both same. But the only difference is the radius of curvature is different. I mean, in this thing, R1 is equals to R2 is equals to R here. Okay. Now we consider for plano-convex lens. If we consider for plano-convex lens, this will be what? On the other side, there is one surface as of the convexo lens, and one is the plane surface here. So this is named as plano-convex lens. Okay. इसको क्या कहेंगे? This is known as plano-convex lens. This surface is what? Concave, and this is convex. So we'll call it as concavo-convex lens. Okay. इसी तरह similar, by going the similar way, we get this kind of lenses, that is biconcave, equiconcave, plano-concave, and convexo-concave lens. These are all lenses there. Clear, students? Yes or no? I hope it's clear. So let me see on the YouTube how many students have joined there again. Back to the YouTube. So on the YouTube, the students are okay. So I'll start it. Just wait. Okay. So one of the JNVs have joined here. Just wait. Okay, so let us start. Okay, I mean, students, we simply are waiting here. So one of the students, JNV, has joined JNV RR. Okay, welcome to today's class. I thought that you people are already given the IDs. I didn't knew this thing because in the previous time I have never given the ID. My work is to take the class here. Okay, that's fine. It's clear. Okay. So we are on the lenses here. So see, the total type of lenses we are having is this one, two number, serial number 3, serial number 4, serial number 5, 6, 7, and 8. These are all total number of lenses. Okay, got it? These are what? Total number of lenses. Now let us proceed towards this. So read this. What is written here? It's principal axis. What is it? Principal axis. So the line joining the centers of the curvature of the two bounding surfaces is called principal axis. This is converging lens, convex lens. This is convex lens. This is concave lens. Diverging lens. This is concave or diverging lens. This is convex or converging lens. Okay, fine. So you must respond here. JNVRR students, please respond here. You can text in the chat box. Audibility issue to nahi hai na. It's I have already cleared it. Okay, there is no audibility issue. You can text in the chat box here. Okay, JNVR students. This is Hyderabad region class. You can see in the YouTube also. It's available properly there. Okay, available on the YouTube. Okay, now let us proceed towards this. So if the lenses are given to you, see, this is, I told already, this is what convex lens, this is what concave lens. So we'll say if this is convex, convex matlab aise. This is concave. Okay. So the formula for this, I mean, everything is having the formula in this chapter, no, ray optics. If you take the mirrors also, there is a formula. If you take the lens also, there is the formula. Hai na? Similarly, for this, there is a formula 1 by V minus 1 by U equals to 1 by F. Remember this always. Okay, mirror ke liye kya tha? There's only one difference between this formula and the mirror formula. That is, in the mirror, the formula was like this: 1 by U equals to 1 by F. Here plus is changed with the sign. This is the substitution, replacement here. Hai na? Rest of the things are same. Got it? Finish. So see, this formula actually, which looks very simple, the lens make a formula, lens formula, 1 by F, where F is the focus. But this is not as simple. I mean, you know, if you see it, if you focus on the F value, this is equals to mu of the lens, mu of the surrounding medium in which the lens is kept, minus 1 upon R1, minus 1 upon R2 here. Okay, clear? 1 by V minus 1 by U, 1 by F, and this is the next thing here. Got it? So remember this formula, how it came, no need of derivation. If you want to understand like this, first of all, we have applied this formula, that is refraction formula by spherical surfaces, N2 by V minus N1 by U, N2 minus N1 by R for this surface. Then we have applied the same formula for this surface. Then you applied the same formula for this surface. Okay. This N2 by V minus N1 by U, N2 minus N1 by R. So when you're applying one first time the formula for this, then again you're applying the formula for this. So what you will get ultimately when you will do some modifications, you will get the value of 1 by F as equals to this. See, N2 and N1 you can consider like this. N2, suppose I'm taking a converging lens like this. So N2 is the refractive index inside, that is mu of the lens. Surrounding medium you can consider like this. The side one is this. mu s. Okay, or if you're taking a diverging lens, the conditions are same. Lens के अंदर का surface, it is made up of some other refractive index and surrounding medium in which that lens, which contains inside some refractive index of the medium, okay, surrounded by some other refractive index. I mean, the medium in which it's kept must be on both the sides same. This you must remember. Okay, is this in clear, students? Okay. Okay, now let us proceed. Let me see the YouTube students, what they are doing there in the class. Okay, some important points to consider here are this. A ray should be paraxial. Paraxial means what? Making a small angle or near to the axis, parallel to the axis almost. Hai next thing what? Any next thing? Is this VUR, of course, this is from the beginning. Whether you are taking concave, convex mirrors, whether you're taking a slab, whether you're taking a refractive surface, curved one, for all of these things, you have to put VU, R1, R2 with sign. R1 is the radius of curvature of that surface and the ray strikes. Lens should be thin. Remember this thing. Lens must be what? Lens should be thin. It's not thick. Why not thick? Because of the lens. Say, suppose it's a lens. If the lens is thick, what's going to happen? Ray may enter it. Some ray will go in a particular direction, showing the divergence and image formation. I mean, convergence or the image formation maybe. But some rays will be going here and there. So it will be very random. This will give a distorted image. Even it may happen, image will not, you will not be able to see proper image of the object in front of the lens. Maybe magnified, or if you're taking microscope, it's like zoomed. Okay? And the last point is this: medium on both the sides of the lens should be same. Remember this point always. Medium on both the sides of the lens should be same. Medium जो होना चाहिए, both the sides पे same होना चाहिए. Suppose ये lens है. Mu L is the medium of the lens. Surrounding medium is mu S. Mu S. ठीक है? याद रखना हमेशा. Always remember this thing. Now let us talk about focus. What is this focus points? So the point is this. This is what? Converging lens. See, if the rays are parallel to the optical axis, this is what these are the rays which are parallel to the optical axis. Okay. So when these rays parallel to the optical axis, paraxial, okay, and after passing through the lens, they meet at a particular point on the other side like this. Okay, they meet or they appear to meet. Okay, this is known as what? Okay, so did you mute yourself? Okay. Sham, is there an issue?
No, bro, you continue.
Achha. Because one of the students now joined and he's like, he left it. Okay. One JNV student now joined, then he left. Okay, so what I was saying is this. If the rays are what? Parallel. Hold on one second, students, hold on 1 second, okay? Okay. Okay, so what's the thing is, if the rays are parallel, to the optical axis, paraxial means these are near to this rays, okay? So when they will come like this and they'll meet on the other point, this is known as what? Focus here, okay? And remember this formula, 1 by f is equals to what? Mu L upon mu S minus 1 multiplied by 1 upon R1 minus 1 upon R2. Okay, this is known as what? I've already told you, this is lens maker formula. Remember it, it is what? Lens maker formula like this. So you have to remember this formula. We have already seen it in the rest of the classes. So what we are going to do is this, we'll solve the numericals based on this. Okay. After this, we have to complete fast our topic of prism and optical instruments first. Okay. So these are some simple symbols of, you must know this thing. This is what? A symbol for converging lens. This is what a converging lens symbol. And this is what? This is diverging lens symbol. Okay. This is again converging lens symbol. This is diverging. Just remember this thing, not to focus on these points, rest of the things. Okay. So let us now solve this question. It's very important because without application, it will not work. See, it is asking here in the question that calculate the focal length of biconvex lens in air. So biconvex is this kind of lens. Okay. Biconvex is this kind of lens. So it is having radius of curvatures different and different. Suppose this surface, if I consider it is having some different radius of curvature, and for this surface, if I consider it is having some different radius of curvature. Okay. Internal medium is having the refractive index as, lens ka refractive index is 1.5. Okay. If we consider, so it's given the radius of its surfaces are 60 centimeter and 15 centimeter. What does it mean? It means like this. If you consider this as a first surface, so you will say its curvature will be, it's here in this direction. Okay, JNV Chitradurga students, you have joined. Welcome to today's class. Okay, so we have started the lens topic, but I am now on the numerical based on the lenses. Okay, so just please be very much focused here how I'm solving the numericals. Okay, after that soon we'll switch towards prism and optical instruments, because this zone is like, it's, we have left, I mean, we are, a lot of the topics are remaining in this class, you know. Okay, so if you're considering this as the first, so the radius of curvature for this will be 60. If you're considering this as the second one, then for this the radius of curvature will be 15. Okay. See students, my plan is this, I want to complete it soon. Okay, JNV Chitradurga students, my plan is to complete it soon, ray optics now. So I'll be fast in this class. Okay, 30 minutes are remaining, 30 plus minutes are remaining. I'll try to complete all the things. Okay, so we'll see in one short class. Okay, so please be focused. So formula which I've given is this, ki focus ka formula, remember this, it is mu of the lens, I mean refractive index of the lens inside medium, okay, of which thing the lens is made, and mu s is what? When the lens is kept in a particular medium, so on the both of the sides, I've already told you, the surrounding medium is having both same refractive index, okay, -1, and this is 1 upon R1 minus 1 upon R2 there, okay. So mu of lens will be what? 1.5, and mu of surrounding medium, you will say what? It's air here, okay. So whenever it's not given, although it's given here, it's air. So we'll write it as 1 minus 1. R1 will be what? R1 is 1 by 60. R2 will be, with sign and conventions you have to put. We're considering this to be positive from the optical center. So we'll say R2 will be what? See, okay, let me write it here. Suppose I'm keeping the object here. Suppose I'm keeping the object here. Okay. So if this is 60 centimeter in this direction, so passing from this, the rays of the objects are like this. Okay. So if this is R1, suppose, okay, let us take it 60 centimeter. Okay, first one, 60 centimeter. So I will say I'm going in the direction of the object rays. So this is positive. Okay. If we are going against the direction of the object rays, it is negative. So for R2, if I'm going in this direction, it is against the object rays. So I will say it is negative. So I'll put R2 negative here. Okay, put kar do. So negative will give you the positive result. Net is this 15 centimeter. So solve this thing. It's very easy. So this is what? 3 by 2 minus 1. And this is 1 by 60. 60 plus 50, I mean 60, 15 LCM will be what? 60, take it. This is what? 4. So ultimate answer you will get is half 5 by 60. This will be what? 12. Okay, so you will get 1 by F as 24. Ultimate answer you will get this. Focus is equals to 24 centimeter. And remember this thing. Conclusion, we can do something. I already told you I'll be fast. Okay. So conclusion, you can do this. Okay, Srinivasa Rao, you have joined. Welcome to the class.
Do you want pen and paper?
Why you are late? I want to know the reason. Why are you late? People, what happened? Please mute yourself. It's happened. Why are you late?
మెటీరియల్ మొత్తం ఆల్ అంతా దీంట్లో డంప్ చేస్తాం అన్ని వీడియో అంటే
Okay. Please mute yourself.
మెగాబైట్స్ ఇంత మెసేజ్ వచ్చి పడే లోపల
Please mute yourself. Good. So you have joined, that's good. Okay. So I have founded, you can switch the, I mean, you can see the YouTube video again. You'll get how I founded the focus. And there are many videos available on this topic, like again for the Chandigarh region, Hyderabad region, in the same YouTube, Avanti Live 13. So you can see again and again the videos. Okay. So I'll be now progressing towards the second thing. Okay. Before that conclusion. So see, whenever you're finding for any kind of lens, the focus, okay, if the focus is coming to be positive, you will say this is what? Converging lens. This is what? Converging lens. Okay. And if the focus is coming as negative, you will say this lens is what? It's diverging lens. Converging and diverging. See one thing. This is for converging lens. This is for diverging lens. Symbols we have already seen. See, I've told you, no. For resistor, see, resistor actually doesn't look as we draw. See, we give it a very simple symbol for circuit diagrams, hai na? For resistor, you know, some resistors are like very mini, some are like big, hai na? Different structures are there. For capacitor, you know, the capacitor looks how in practical conditions, but we make how, and by pen paper representation, we show this capacitor as this. Do you agree? Okay. Similarly, the lenses practically look like this, somewhat like this. Okay, from one dimensions. I mean, if you see on one side, but for paper pen representation, for simple representation, we can show these lenses as like this also. Got it, students? Hai na? Clear hai na? So remember few points now. Again, some important points for you people. Since for converging and diverging lenses, now we can use converging or diverging lens ke liye we can use this. For converging lens, this for diverging lens. These are two symbols. Okay. And see, focal length of the lens depends upon the surrounding medium. Why it is? I want the reason. Any one of you? देखो मैं बताता हूँ. Before this question, remember the focal length of the lens is defined as mu of the lens, mu of the surrounding medium minus 1 and 1 upon R1 minus 1 upon R2. Okay, this is what? Focal length. Okay. If the focal length is positive, okay, it implies it's converging lens. If the focal length is negative, it implies it is diverging lens. Okay. If the focal length is positive, it implies what? It is converging lens. Sorry. If it's negative, it implies what? It is diverging lens. Remember, हमेशा याद रखना इस बात को. Okay. So here I will say. So this is the same point I've already explained you now. You know, focus positive implies what? Converging lens. Focus negative implies what? It is diverging lens. Okay. Now let us solve one more question. Then we'll switch fast to the prism. See, calculate. It's asking here. It's asking from us here that calculate the focal length of the lens shown in the figure. I don't know what it will be, but let us find it out. And guess. Do you know, will this converge if the object is kept like this? Suppose some candle is kept like this. It's not a candle. It looks like a home. Okay, now it's candle somewhat. Suppose the candle is kept in front of the lens. So if you see the image, rays are coming from this. Okay. So what do you think? How the image will be formed on the other side? It's be like converging, or like the rays will be go and diverging. So that we can guess from the focal length. If it's positive, it will be converging lens. If it's positive, it will be converging lens. If it's negative, it's diverging lens. Okay. So see this formula. Formula kya tha? It was mu of the lens upon mu of the surrounding medium. Okay. Minus 1. Then what? Then 1 upon R1 minus 1 upon R2. Very easy. These are just, you have to apply the formula and get the answer fast. Okay. If you see here carefully, if you focus here, mu of the lens kitna hai? Mu of the lens means inside the lens, refractive index. It's given here 1.5. Mu of the surrounding medium kitna hai? Mu of the surrounding medium is here. How much? Batao students. Mu of the surrounding medium kitna hai? How much it is? Anyone? It's air, no? So it is 1. R1, if you're taking this surface, so it is towards this direction, in the direction of the object rays. So I will say it is positive, that is 30 centimeter. Okay. R2 is for this. So it is again in the same direction, 60 centimeters. So it is also positive. See, unless, like the previous case. Okay. I mean, if we consider the previous case we have seen, let's say this question, let me tell you, some students were not here. For this kind of lens, it was curved like this, so R1 will be here. Second is like this, so R2 will be here. So for one, if you're considering positive, next will be, of course, negative. But in this case, both R1 and R2 are what? If you see here, both R1 and R2 are positive here. Okay. So I will write here 1 by F. I will write here 1 by F mu L upon mu S. Mu L kitna hota hai? Mu L means 1.5. Mu S means 1 minus 1. ठीक है. R1 कितना है? R1 is positive 1 by 30 centimeter. R2 is 60 centimeter. समझ में आ गया? It's completed. ठीक है. So you will get the focus like this. 1.5 minus 1 कितना होता है? What is 1.5 minus 1? It is 3 by 2 minus 1. And if you solve this thing, this will be 1 by 30. 1 minus 1 by 2. ठीक है. समझ में आ गया? So this will give you 1 by 2 answer. This will give you 1 by 30. Again, this will give you half. So ultimately, you will get focus as equals to, implies that 2 to the 4, 4 to the 12. So you'll get this 120 centimeters, 1 by F. Okay, 1 by F. And this will be equals to 120 centimeters. So focus we are getting here is 120 centimeters with the sign in conventions. And you can observe one thing. Here the focus value, students, is positive. Focus value kya hai? Yahan pe focus value is positive. It means this lens which is given on the screen is what kind of lens, students? It is converging lens, converging lens, converging lens. Okay? It is what? It is a converging lens. Okay? So let me conclude at the end. Okay, this is one more question for you. Let us solve this. Conclusion its conclusion is like this, that lenses are of two types. Okay, till now we have studied lenses are of two types, converging, basically two types. Formats are two, different structures you can find, and diverging. Okay? But for both of these lenses, we are using one formula for the focal length, that is this. Mu of the lens, mu of the surrounding medium minus 1, 1 upon R1 minus 1 upon R2. Okay? So this question I pasted on the slide is a homework for you. You have to solve it yourself. Remember this. This you will solve yourselves. Okay? Clear, students? Okay? Is it fine? So I'll be giving you this question on the slide. Now one more topic, that is transverse magnification in case of lenses. Transverse magnification in case of lenses. What is this transverse magnification? Transverse means perpendicular. See, understand one thing. We started with the refracting surface. I mean, the topic which is just previous to this. Refracting surfaces, we have seen how the equation was there for finding the images n2 upon v minus n1 upon u equals to n2 minus n1 upon r. By using this equation two times and doing some modifications, we get the lens maker formula. 1 by v minus 1 by u equals to 1 by f. Okay? And we know, we get to know here this 1 by f is given by mu l upon mu s minus 1 upon r1 minus 1 upon r2. Okay, clear? So, when we started with the reflections, not reflection, reflections for the plane mirror, we have seen this thing, that even for the reflection for the plane mirrors, there was some quantity known as, defined as magnifications. And in that, the magnification was given by height of the image, height of the object, v by u with the sign minus v by u with the sign and conventions. Okay. Similarly, for this also, that is, if see this is the simple symbol paper pen representation. It's a paper pen representation of converging lens. Practically, it will be 3D. No, it looks good, but now it's a paper pen representation. It's simple. It's a converging lens. And if the object is kept like this is the height of the object in front of the lens, and this is the height of the image. Okay, so what you will see, that image formed is in this side converging. Okay, and you get the magnification this. Remember, magnification is defined as height of the image upon height of the object. Okay, follow this quantity, and what are the result you get on the right hand side? That's the answer. Here we are getting v by u. These are some of the like parts of the derivation. Okay, no need to consider this. When you will see the PDF, you can understand yourself. It's very easy. Geometry they have used. They've just applied tan theta perpendicular upon base and tan theta here, that is perpendicular upon the complete base, that is v. Compare both the tan thetas are same, you'll get this result. This is plus v by u, not like this, that is minus v by u. For see, this formula is for what? This was the transverse magnification in the reflection case shown by concave and convex mirrors. Okay, fine. So transverse magnification is completed. Now I'll solve one question and then we'll go directly towards optical instrument. I've skipped prism for your class. What's the reason? Because lenses are directly been linked with the optical instrument. Not like that. It's not like the prism, okay? Unless like the prism, okay? They're directly linked with the what? Optical instruments. Okay, see, this lens is what? Converging lens. Students, समझ में आ रहा है ना? Every one of you, जिनमें चित्रदुर्ग students. I hope it's clear to you. है ना? This is what converging lens. See, this is an object which is having the height is equals to 2 centimeters. Okay? And object distance is equals to u equals to 30 centimeters. Okay? Focal length already is given here of this lens is 10 centimeters. Focal length is given as 10 centimeters. Now what you need to do? They're asking you find the position height, nature also. Simple, very simple question. So apply this thing. 1 by v minus 1 by u equals to 1 by f. Okay. So 1 by v we want, v quantity we want, u quantity is how much it is? 30 centimeters. Focus kitna hai? Focus is 10 centimeters. Positive it's given. Focus is already given to you 10 centimeters. Okay. U negative hai, positive hai. So suppose if this is the optical center. So if you're going towards the object, you're going against the object rays. So it will be minus 30 centimeters. It will be minus. Okay. So this the answer, net answer will be this 1 by 30. Focus is positive. This is 10. So you will get 1 by v 1 by 10 minus 1 by 30. So when you will solve this thing, you'll get what answer? 2 by 30. This is equals to 1 by 15. So image which we are getting here is 15 centimeters, students. Image kitna milega? 15 centimeter distance. Okay. So the conditions will be like this. If this is a converging lens, I've drawn in front of you. Or okay, Jinvi Ranga Reddy students have joined. Welcome. Okay, but few minutes are remaining. So, but don't leave. Okay, in 15 minutes, I'll try to complete half of the part of optical instruments. It's directly connected with the lens formulas, hai na? Lens thing, whatever we have studied. So this is converging lens, and if the object is kept here, okay, it's having some height. U equals 30 centimeters. So we get what answer? That V is 15 positive. It means from the optical center, it's like this V 15 on the other side, and this is the height of the object. Height of the image, I don't know how it will be. So I'll apply the magnification, which is defined for the lens as height of the image upon height of the object, V by U. Okay? Image kitna hai? Height of the image is how much? I don't know. It is given here. No. ऑब्जेक्ट का हाइट दे रखा, सॉरी ऑब्जेक्ट का हाइट दे रखा है, ठीक है, ऑब्जेक्ट का हाइट दे रखा है 2 सेंटीमीटर, v दे रखा है 15 सेंटीमीटर, u is if you go from the optical center towards this direction it's minus, so within sign convention it's minus coming. So through this I can say like this will be half minus half, object is 2, so this will give me net answer as, it implies this height of the image I will get as minus 1 centimeter. ठीक है, so it will be like this, height of the image minus 1 means inverted, because if this is principal axis passing through the optical center of the lens, so upward on both the sides is a positive direction, and down is negative direction. Okay, ठीक है, so through this we can say like this, what we can say, nature, what the interpretation you will do of the nature of the image, क्या interpretation करोगे, you will say like this, image is on the other side, it's real but it's not virtual, you know, it's passing, the rays are coming, and this is a lens, rays are coming outside of this, ठीक है, image is real but it is what, it's inverted, image is real and it's inverted, remember this thing, image क्या है, real है, ठीक है, it's inverted, ठीक है. So now students I'll be fast for the optical instruments, so are you ready? Yes. So let us proceed towards the optical instruments. Hold on, this some other slide has come in between. Just hold on 1 second, students. Okay. Yes. So now we are back on the optical instruments. I have to remove the remaining parts. Just hold on. Okay. First of all, text. Are you having any doubts? Anyone of you is having any doubts? You can text here in the chat box. Anyone of you is facing any doubts? You can text in the chat box, students. Any doubts? Anyone of you student? Lens complete कर दिया मैंने. Okay. If you switch back to the YouTube video, you will be able to see it properly there. ठीक है? Lens हो गया. Now we'll start somewhat optical instruments. I'll just complete simple microscope. Don't worry. सारा नहीं करेंगे because we're not having a lot of time now. I'll just complete a simple microscope. ठीक है? Let's see here. Okay, finish. Okay, I'll just complete simple microscope. Okay. Yes, it's available there now. So we have completed our lenses topic. And now we'll switch towards the prism is remaining actually. Prism is remaining. Okay, so we are having only few minutes remain. Okay, so I'll start the prism. Leave that microscope. Okay, so at the end, with the series we'll complete it because I actually want 15 minutes for this. So I'm completing this prism now. I'll not complete. I will just give you introduction. Okay, so see what is happening here. If you focus on this structure. So remember what is prism first of all. So just by looking here, you can say prism is something which is having 3 glassy surfaces which are connected like this, making some angle with each other. Okay. So this structure in front of you students is known as prism. This structure is known as prism. Okay. Suppose a white light is passing from one side of this prism inside it. Okay. So when it passes, so it's like a book, students. Just see this book in front of you. See, this is what a book. Okay. See, slab is what there is 2 difference. Remember, I'm just showing you the introduction. Okay. So there's a difference between a glass slab. Suppose there is a glass slab. If a ray is passing from it, it will go on the other side simple. This is the condition for the glass slab. So let me demonstrate you this thing. I mean, I'm not having the glass slab, but a little bit. This is what. So this is what. This is a book in front of you. Okay. If the ray is passing from this on this side, like this, it will come outside on this side. This is the case of glass slab. But what is the prism case? Prism case is this. Suppose if you turn this book like this, little bit angle if you make, okay, if you see the corner edges, if the ray is going like this, it will come outside in some other direction, not as compared to the glass slab, it's coming parallel. Okay, parallel nahi aayega. Suppose the ray is going like this, on the other side you will find it will come like this. So there is a divergence. This is known as emergent ray, but it's not parallel. It's changed with the angle as compared to the incident ray. Okay, it's changed with the angle as compared to the incident ray. And this phenomenon in front of you, students, nothing but dispersion. Why? Because you can see the white light has been dispersed into 7 colors by the prism. And this we can see also in the lab, isn't it, students? Hai na? JNV, Rangareddy students and Chitradurga students. Is it fine? Is it fine? Dispersion is what? When the white light is passing through this prism, when the white light, you people have opened the camera on the top. It will not work there, okay? So what I'm saying is this, when the white light is passing through the prism like this, when it comes out as an emergent ray from the other side, it will not come as a single ray, but it will show you a band of different colors. This band is known as VIGYOR. VIGYOR का मतलब होता है violet, indigo, blue, green, or yellow, orange, red. Okay. Now, refraction through prism. Let us talk somewhat about refraction a little bit. Then I'm ending the class. At 55, I'll end the class. This is a prism. Okay. This angle, remember, prism is made up of what? Suppose you take 3 glass plates. Remember, 3 glass plates. Connect 2 plates like this. Connect 1 plate at the base and close the system. Or you can take a big material which is from very glassy and somehow, you can make it a shape of like prism and take it out. Extract it out. Okay, so this gives you prism, and this angle is known as, students, A, which you name as angle of prism. This A is nothing but it is equals to the angle of prism. Remember this thing. I'm telling you what are the points inside the prism. And see, if the ray is incident like this is what? It's an incident ray. Okay, and on the other side, this ray when passes like this from one side to other side, it gets somewhat shifted like this, and when it comes out, it's an emergent ray now. So this is now what? Emergent ray. Okay, this is incident ray, this is emergent ray. Okay, this is R1, this is R2. These are what? Angle of refractions. Okay, refractions kaise? Let me tell you. Suppose this ray, this incident ray enters like this. It is making an angle I with the normal to this prism line. Okay. On the other side, when it is turned, it is making an angle R1 on the other side. Okay. And again, when it passes from inside the prism, now this R2 is nothing but the incidence angle for this surface, making with the normal to this surface. Again, now if the ray is passing from R2 is what? Incidence angle, but the inside ray of this prism is now passing from a denser material, that is glassy material of the refractive index 1.5 of this prism. Outside what? From denser glass material to the air. So it will bend away from the normal. That's why now this emergent angle where E is greater than this R2, and here this I will say I is greater than this R, because it's rarer to denser. Okay. So this will give you a pattern, a shift in the degrees of the rays direction from outside inside prism, then outside prism. Okay. So this complete system, this complete picture in front of you is the prism working. I mean, how the rays goes, how the ray turns, all this thing. Now, if you see, if we'll do some derivations, it's not required. But remember this thing, ultimately you will get a deviation. So this angle in front of you, students, let me highlight this. This angle in front of you, this del, 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 this angle is known as angle of deviation. Deviation. Why? And this is the formula in front of you. Angle of incidence plus angle of emergent, combine them, minus them with the angle of prism. Ultimate derivation you will get like this. and this is complete given on your PDF. Okay, not required. Formula you must remember. Requirement is this. It is for all students who want the conceptual clarity in between. So you can see everything will be given here. But what is this angle of deviation? If you see, I'm ending at 355. What is this angle of deviation? Angle of deviation is defined this key by how much angle the incident ray is turned from its initial direction. We'll say this angle is known as angle of deviation, or you can say the angle which the emergent ray is making with the incident angle ray direction. This angle is known as angle of deviation. So I'm writing in front of you the definition of angle of deviation. See this, and then we'll end the class. Okay, remember. So we have completed up to angle of deviation. So I'll say like this. What is angle of deviation? It is the most easiest definition is this: the angle with the emergent ray. You can say like this: the angle by which incident ray has turned from its initial direction and appeared as emergent ray. Okay, I mean something is going like this, and it is turned with this. So from the initial direction, it is turned like this. So this angle is known as angle of deviation. Okay, and it's given by this. If in the prism they have given you these values, angle of incidence, emergent angle value they have given you, and then angle of prism they have given you. So you can find the angle of deviation with this value. Okay. So in the next class, students will be seeing variation in the angle of deviation with the angle of incidence. You will be able to see that for a particular angle of deviation, there are, according to the graph, defined two angle of incidence. Okay. So that is for the next class, not for today. Best of luck, students. Already tested here. We'll meet in the next class. Okay. Bye bye, everyone. Take care. Bye bye. Okay. So we'll meet in the next class. Class is ended. For reference material, take HCV. Solve HCV for reference material, and you see the YouTube videos. Many of the YouTube videos are available on the Avanti Live 13 channel. Okay, got it? Channel, you know. See your previous WhatsApp links. Always that link is never changed. Okay, so come with that link. Okay, bye bye everyone. I'm ending the class.